In this lecture I will discuss about even and odd signal. So the second part is part of classification of signal, that is, one is energy and power signal, next is even and odd signal. What is even and odd signal? A signal is said to be even if x of n equal to x of t is equal to x of minus t. That is, x of t is your signal. If you take the reversal, time reversal, x of minus t, both the signals should be equal. Suppose this is the signal x of t. You take the minus of the signal, you take x of minus t. That means not the minus, take the inverse in with respect to time domain. That means you have to take the mirror image of the signal. Okay, x of t is this. What happens if x of minus t? That means t values should be changed like that. Okay, x of t is defined for -1 to 1, so x of minus t also you have to change like that. You know how to change it. Okay, so take the mirror image. X of t is this, x of minus t means you just flip the you take the time reversal. -1 become +1, +1 become -1, so x of minus t. So x of t and x of minus t both are equal, then we can call this as even signal. Okay, now consider this signal. X of t is from -1 to 1 like this. Take the x of minus t. You just take the reversal. -1 become +1, +1 become -1. You just take the reversal. Okay, you just take the reversal of the signal. You will get this signal. Normally we know how to take the reversal. For example, for things getting clear, I'll show. X of t, x of t is defined for -1 to 1. Okay, -1 to 1 x of t is defined, and look at here. Here I am changing the t to minus t. So here t changes to minus t. So -1 minus t less than 1. Okay. So to make it t, you have to multiply entire time by a minus. So 1 minus become +1 greater than t greater than 1 greater than t less and t greater than -1. This minus become plus, less than become greater than. So again it changes to -1 less than t less than 1. That means if you take the time reversal, you get the same signal only. Okay, similar to the case here. X of t, take the time reversal, you get the same signal. This is even and odd signal. What about odd signal? In odd signal, if you this is x of t, if you take the time reversal x of t and you will shift, you will get the same signal. That means x of t is, this is x of t, you take the time reversal, time inverse, this is x of t. Okay, so look at this, this is x of t, it is defined for -1 to 1, and these are the two amplitudes. X of minus t, you shift this signal. That means you take the mirror image, or you flip the signal like that. Normally for taking minus t, normally we check for mirror images. Okay, and with respect to y axis. So if you flip this -1 become +1, this +1 become -1, -1 become +1. That means this signal changes to here and this signal changes to here. That is, this signal is to here and this signal is to here. That means this is shifted to here. That's why I drawn like this. Why? Because this +1 become -1. So this signal changes to this coordinate like this, and this signal, this part changes to this coordinate. Why? Because -1 become +1. Amplitude won't change. Why? Because here we are just shifting, taking the time reversal of a signal. Okay, so this become like this, -1. This time become right side, this signal. So -1. So 1, amplitude is same only. So you compare these two signal. Okay, you compare these two signal, check both are equal or not. No, both are not equal. But what happens if you again shift the signal? Suppose if you put a negative sign over here, that is minus x of this is minus t, shift the signal. Minus x of minus t means your entire time you are multiplying with a minus or taking the reversal of the entire signal. Minus x of minus t. At that time you have to take the mirror image at the x-axis. Minus x of minus t. This become that means it affects the amplitude. Minus x of minus t means plus 1 become minus 1, minus 1 become plus 1. How will be the signal? Minus 1 become, you're taking minus x of minus t, okay. At that time what happens is this plus 1 become minus 1 and the signal goes like this, because this area, this 1 become minus 1, so this signal goes downwards, okay. It will be like this. And what happens to this minus 1 become plus 1 and this signal goes upwards. Why? Because a negative sign here. So what is this? This look like the original signal, right? These two are original. This look like the original signal. So this x of t, if you take this time reversal, then shift the signal with the minus, then you will get the same. That means x of t and minus of x of minus t both are equal, then it is called odd signal. Or in other way we can say that if x of t you take x of minus t, both are not equal at that time. If you shift again minus, flip again minus, so x of minus t. So if x of t and minus of x of minus t, you write x of t, then take minus of x of minus t. If both are equal, then we can say that this signal is an odd signal. Okay. Here so here x of t you take minus of x of minus t. If both are equal, then you can say that it is an even signal. Okay. So next is periodic and non-periodic, or it is called a periodic signal. A periodic function is one which has been repeating an exact pattern for an infinite, and it will continue to repeat that exact pattern for an infinite time. That means this is a periodic signal. See, a signal is a pattern. This is the pattern. So it goes up, downs, goes up and downs. It's positive, negative, positive, negative. This pattern repeats for an infinite time, both in negative and positive. It is repeating. No, here it is repeating. This is repeating actually. This is repeating. This is also repeating. So this is called a periodic signal. A periodic signal have a periodicity. A certain period of during this period, the signal quantity, shape, it is repeating over an infinite amount of time. Okay. So look at here. This is also another periodic signal. This pattern is repeating over infinite time. Okay. That is periodic. A periodic is one which has been repeating an exact pattern for an infinite time. It will continue to repeat that exact pattern for an infinite time. So look at this. This is not a periodic signal. Why? Because a pattern is repeating for positive side only. For negative time, for negative side, before 0 it is not repeating. There is 0 signal. There won't be any signal, and it is designed only for positive value. So this is not a periodic signal. So signal is periodic. G of t is equal to g of t plus nt for n for any integer, and t is the period of the signal. If g of t equal to g of t plus nt. So this is the periodic signal. That's about this. Next is causal and non-causal signal. A signal is said to be causal if x of t is equal to 0 for t less than 0 and x of n equal to 0 for n less than 0. That means x of t is 0 for t less than. That means it is defined only for t greater than 0, right? We can infer like that. X of t is 0 for t less than 0. Take this signal u of t minus 5. It will start from plus 5 like this. Is the signal is defined for less than 0? No, it is not defined for less than 0. It is defined for greater than 0 only. So x of t is 0 for t less than 0. It is a causal signal. That means u of t minus 5 is defined only for greater than 0 only. By looking itself you can understand. What is u of n minus I? If This is the time value. For continuous signal we represent t, for discrete signal we can represent n. Okay, f t minus 5 means it is starting from plus 5 and it is continuously going. A of n minus 5 means from 5 it is going from n. That means here timing value it is continuous. Here the discrete values of time, that is represented by n, and this from plus 5, 6, 7, 8, 9, 10 like that. For each and every discrete time there is having an amplitude like that. This is the discrete signal. In the beginning class I told about discrete and continuous signal. Okay, this is the discretized signal. If you make discretized, if you sample the signal, you will get this discrete. That sampling means you tap the values of this amplitude at a discrete instant of time, you will get this signal. So this is u of n minus 5. This is also not defined for less than 0, it is defined for greater than 0. What about anti-causal? Anti-causal signal is also defined for less than 0 only, it is not defined for greater than 0. That is, here we can represent x of t is 0 for t greater than 0. What is non-causal signal? If the signal which covers 0, that is non-causal signal. See, look at here, this signal covers 0. See, this signal covers 0, so it is non-causal signal. Defined for 0, that is less than 0, defined greater than 0, defined, and is defined for 0, that means it is covers 0. Signal which covers, look at here also non-causal signal. Signal is covering 0 from a negative to positive, so it is non-causal signal. Next is deterministic and random. If the value of signal can be predicted for all the time t or n in advance without any error, it is called a deterministic signal. X of t is equal to e raised to minus t in u of t. That means this signal value can be predicted for all time interval, or for all the time we can predict the value. For this signal, such a type of signals is called a deterministic signal. What is random? Signals whose values can be predicted with complete accuracy for all the time, known as random signal. A signal whose values can be predicted with a complete accuracy for all the time. For example, a thermal noise generated by resistor. Look at here. This thermal noise generated. You know what is thermal noise? It is normally generated in resistor. It is due to the random movement of electrons in the component, the resistor. Okay. So intensity of thermal noise depends upon the movement of electrons that cannot be predicted accurately. See, intensity of thermal noise depends upon the movement of electrons in the resistor. Okay. So this movement of electron, can we predict the movement of electron? No, we cannot predict the movement of electron. So the intensity of the thermal noise we can't predict. Such a type of signal is a random signal. That means the value cannot be predicted accurately for all instant of time or some instant of time. This is normally characterized by mean or mean square value. If a signal value is predicted for a particular instant of time or all the instant of time, such a type of signal is called a deterministic. If it is not defined for all the time, then it is random signal. That's about classification of signals.